lecture on network analysis, and today in my last two lectures I told you how to solve a network problem using graph theory and use two methods. One is the nodal method, where the target was to calculate the node voltages, and another was the loop analysis method, where the target was to find out the fundamental loop currents. Once you know the node voltages and fundamental loop currents, you have really solved the circuit. Now, today I will tell you about how to solve the network problem using graph theory, but using cut set method. Okay, that is, this is the network. Each branch in general will, kth branch has been shown, put k equal to 1 to 6 here. In general, all the things will be present in a branch. If no current source is present, open this branch. If there is no voltage source present, Vsk will be 0 and so on. But do not put Isk equal to 0 and short it, that you should not do. Okay. Anyway, so today we will be discussing about using cut set matrix, and cut set matrix, you know that what you do is this, you draw the, I will just briefly review what you know about Q matrix. You draw the choose any one tree of the network. This is what I have chosen, this is the tree, these are the links, and these tree elements are called the twigs. So, I told you that in this network, if these twig voltages, that is this voltage across 1, across 2 and across 3, if these are known, you can find out all other element voltages. And if you know element voltages, you know node voltages and so on. So, this method, so Q matrix, how to form it, I am not discussing. Once you draw the tree, you can, you know about the Q matrix. Now, what will be the basic equations here? Once again, you start with the kth element, where this is the network, that element branch, and here you write down the potential difference between V k as this one, this we have done several times. Then here it is equivalent to some nodal analysis, is it not? This is like nodal analysis. So, you have to apply KCL equations. So, first find out IEK, this current IEK, express it, take this to this side, divide by ZEK, then IEK will be admittance into VK minus ISK minus YEK VSK. Now, if you do it for all the elements, that is IE1, IE2, I3, it can be a column matrix. Here it will be a diagonal admittance matrix. This will be once again a column matrix of different element voltages, and these are the source voltage and current. So, source voltage and current, keep it always on the right hand side. That also we have applied previously. Now, after you do this, you remember that Q, this matrix, into I e is equal to 0. This is how do I get? By applying KCL at the cut set, at the fundamental cut set. This is known, and another relationship is known, that is Q transpose into the twig voltages, is not, is equal to the element voltages. That is, if you know the twig voltages, you know all the element voltages, and if you know all the element voltages, node voltages can be calculated and so on. So, this is the fundamental equation to begin with here. I get up to this. Then what you do is this, you pre-multiply this equation with q, both the sides. Therefore, it will be q into I e is equal to q into V e pre-multiply both the sides by q matrix minus q into y matrix was already present. Thank you. Q into y into V e. This will be the first term, and this will be minus q into I s. I s, V s are column vectors, V is column vector minus q into y into V s. This will be the thing. Now, obviously, q into I e will be equal to 0 because of this. So, q into I e, this must be equal to a 0 vector, column vector. So, from this I will be, so this is the thing. Now, or, so this is equal to 0, 0 equal to this one is equal to q into the nodal admittance matrix y into V e. V e can be written as in terms of tweak voltages. Tweak voltages. If you know the tweak voltages, all the other element voltages can be known. If you know the node voltages, all the voltage of the other elements can be known. So, that was the spirit. So, this is q into y e, but V e, for that I can write down q transpose into V tweak voltages. From this, substitute this, and this minus q into I s minus q into admittance y into V s. See, here it is current, therefore, right hand side also dimensionally should be current. So, you can easily remember this is current, q matrix has got no dimension, only plus 1 minus 1 entry. So, it is in ampere and V s in volts, and volt pre-multiplied by admittance will give you also ampere, since q has got no dimensions. So, this is the thing. So, this equation is the central equation to find out the currents in the circuit. So, this you copy and paste it in the next page. So, this is the thing, and this is equal to 0. Or I can say that my target is to compute this one. So, q into y into q transpose into V t will be then equal to q into I s plus q into y into V s. That is all. So, this is once again the nodal admittance matrix. Earlier we got A y A transpose when we applied nodal method to calculate the node voltages. Here that A should be replaced by Q and the equation is similar. So, this equation can be solved and you get the value of the tweak voltages. So tweak voltages can be calculated. And once you know the tweak voltages, you have practically solved the circuit. That was the whole idea. Therefore, this is the KCL method only, but we are applying at the cut set. And previously, you just see whether I am writing correctly, we got this one A y A transpose. Previously, we got A y A transpose into the node voltages is equal to, it was like this, A into I s source voltages plus Q A into y into P s. So, this was the to calculate the node voltages. And so, these two methods are similar type. You are applying KCL. For this you are applying KCL at the nodes, and for this you are applying KCL at the cut sets. Okay. So, this was the thing. The third that loop method, in the loop method we got B Z B transpose into the fundamental loop currents is equal to this, both the signs were minus there. Anyway, I will just check that this is equal to, but here you see it is Z into I voltage. So, voltage will remain like this. For example, I copied it somewhere. So, I L it will be equal to minus B into Z E. I mean Z, I am writing Z there. So, B into Z into I s. Minus B into V s. So, right hand side is the source, clear. From this you will get the fundamental loop currents, and if you know the fundamental loop currents, then so this is to calculate fundamental loop currents. If you know the fundamental loop currents, you have solved the circuit, it is understood. So, these are the three methods, the final results, and Z is called the loop impedance. This whole thing is called the loop impedance matrix, loop impedance matrix B Z into B transpose. What is Z? A diagonal element. What is y? Diagonal y in all the branches 1 over z E k is y E k. So, like that, so this method, why this assumes importance? Because if the network is large, you just it is solving circuits, this can, you can write some codes. So, that only thing you have to do is Z matrix writing is very simple. You have the networks before you on pen and paper. So, you can write Z matrix, you decide which method you will apply, whether nodal method or cut set method. Based on that, you form the Q matrix from the trees, from the twigs, or A matrix, that is the incidence matrix, or the B matrix, and we know how to form them. So, what are the things to be known from my side? B, if you are adopting this method, then you must know Z, you must know B, you know how to get the B elements. Elements of B are very simple, either plus 1, minus 1 or 0. Similarly, here, and what else? This source currents and source voltage, this is V s. Here is a small correction, it is V s. So, that can be done no matter whatever is the size of the network, this can be done, and then write a small codes in MATLAB or in whichever platform you like and get the currents. A very systematic approach to solve the networks. Therefore, all the three methods I have discussed. Now, this I will of course take a very simple example just to give you a feel what exactly you have to done. I have not taken a very big system, otherwise I myself will make mistake and things will become very, I mean too many steps will be there, too many variables. So, let me give you some example how to adopt this method in this case. A simple network, let us say. For example, you have a network like this. Here is a simple network, which of course can be solved without resorting to graph theory, because it is so simple a network, but nonetheless it will, suppose somebody decides he wants to apply graph theory to solve this simple network event, he can do so. So, suppose this is the network. Here it is suppose 10 volt, here it is 12 volt, here 4 ohm, 2 ohm and 0.8 ohm. This is the thing. Now, what will be the graph of this network? Graph of this network will be, there are only, this is one node, this is one node. So, between these two nodes there is an element, between this node and this node there is another element, and between this and this, if you call this is node A, this is node O, then there is another element. This is the graph of the network, very simple, 3 elements are there. Okay? And then I want to make a directed graph. So, what I will do? I will this assuming the directions is totally flexible, in whichever way you assume. Suppose I have assumed it in this way 1, 2 and 3. This is your A, this is your O. Okay. What will be its tree? One tree let me draw. These are the two nodes. all the nodes should be connected, but there should not be any loop. So, this is one tree, is not, this is one tree, this is one, and what will be the links of this? This is one link, this is one link, this is link number 3 and this is link number 2, this is A, this is O. Got the point? Now, suppose I want to solve it by, I want to calculate the fundamental loop currents for this network. So, I have to form the B matrix. So, it is loop current first B matrix. So, I will write down want to solve for fundamental loop currents. What are the fundamental loop currents? Fundamental loop currents will be IL2 and IL1. You put one IL2 and IL3 decided by the number of links present. So, there will be only 2 links. So, B matrix straight away I can write it as for loop 2 and for loop 3. And how many elements are there? 1, 2, 3. So, write 1, 2, 3. So, B into V is equal to 0, that is the thing. So, suppose you take this one. So, it will be, you start from this point. So, the direction of the link will, if it is this way, assign plus sign here. So, 2 it is plus, then only 1 will be there, that will be minus, and this will be 0, that is it. Loop 3, for this loop, when only this link is present, this is the plus sign. So, plus 1, then once again this 1. There will be only one link present in the loop. So, 3 and 1 form that fundamental loop. So, 1, this will be 0 and this will be minus 1. This is B matrix formation. Now, what will be JD here? So, what I need? So, for this I need this equation, that is let me copy and paste that, so that you understand the steps what I have to do. So, this last equation, let me, so I have to calculate, I want to mention that Z I have to calculate, B I have obtained, and then IS and VS, these two matrices I have to form. So, let us do that. Now, Z matrix will be simply, here let me write Z matrix for this network, it will be simply diagonal matrix and there are only 3 elements. So, for element 1 there is 0.8, so 0.8, others it will be a diagonal thing. For element 2 it will be 4 ohm, so 4, 0, 0 and this will be 0, 0, 2. This is the Z matrix obtained. Now, I have to write IS and VS. Now, there is no current source in any of the branches. So, Vs, first let me write, Vs is equal to a column vector, element 1, is there a voltage source? No, 0. For this element, there is a voltage source present, should it be plus 12 or minus 12? it will be plus 12. Why this element arrow is this way and battery is connected plus to this side. So, and in the third element there is another source that is also plus 10. Is that clear? Yes. The matrix I s, that is current source present? No. So, 0 0 0, that will be the thing. Now, I know what I have to do. I have to calculate then, keep this equation, let me write. So, it will be B, here I write, this is the equation we will be adopting, B into Z into B transpose, is not, into loop currents, fundamental loop currents I L, and this is equal to minus B Z, ZD or Z, whatever you write, but that is a diagonal matrix, Z into I S, source current, minus B into V S. Now, this B is known, Z is known, therefore, I will be able to calculate B Z B transpose, B Z into B transpose. I will be able to, you have calculated that. Which will be, let me write down a bit about this matrix. B is already there. So, B, so this calculation means B, that is minus 1 1 0 minus 1 0 1 B matrix. Z matrix is this one 0.8 0 0 0 4 0 0 0 2 into B transpose. So, B is known, its first row become first column. So, minus 1 1 0 and minus 1 0 1. If you calculate this, then the Z matrix, hopefully it has been correctly calculated, it will become equal to 4.8 into 0.8 into 0.8, I mean the second row into 2.8. This will be this calculation. Clear? Then I will say that I L will be equal to, then B Z you have to calculate, B into Z, and B into V S you have to calculate, V S is known and I S is also known. I S term will be in fact not there, this will become 0 in this particular case. So, it will be simply this matrix, that is this equation I am coming, it is 4.8, 2.8, 0.8, 0.8 into the loop currents, that will be equal to B into V S. So, minus B into V S. So, B was this. So, minus of B into V S will be minus 1 1 0 minus 1 0 1 into that V S 0 12 10. This is V S. Got the point? And this will then become equal to, on the right hand side you will get 12 here and a negative. So, minus 12 and minus 10. Therefore, IL the loop currents will be this matrix 4.8, 2.8, 0.8, 0.8, inverse of this, you multiply both sides into this one, minus 12, minus 10. And if you do that, it will come out to be minus 2, minus 3 ampere. Done. Therefore, loop currents are known, therefore, I will be able to calculate the element currents. Now, one may wonder, it is such a simple circuit, should I do Cartset? Not necessary. By some other simple our traditional nodal method or any other mesh analysis, you can easily solve this. But here it is to highlight what exactly you have to done, you know now, that is a complicated network, formation of B matrix, you have to do once, which have only entries plus 1 minus 1, correctly do that. Then get the impedance matrix is also easy to obtain, see the elements, source voltage and source current column vectors you can easily write. Let it be very big networks, do not worry about that. Calculate this, and these calculations whatever B transpose, B Z, B transpose. So, at the initial stage of your programming, you must give B matrix, source currents and source voltage. Then you ask the computer to calculate B Z, B transpose, all the numerical values are known. Inverse, write some programming in MATLAB, it is readily available, and then you get the loop currents, and after you get the loop currents, you know the branch currents. I stop here. In the next class I will show 2 more examples. Thank you.